So let's talk about finding sine, cosine, and tangent. So you already know that if I put the angle right here, the opposite side of that angle is right here. But if we look at it, that's actually going to give us that y value. So if we look at this point right here, this point is the x value, which is this length right here. That would be x. And then the y value of that point would be that length right there. So that would be y. And then this length right here is r. So if I'm looking at a point on the unit circle on the xy plane, and I want to find the sine of it. So remember, sine is opposite over hypotenuse. But in our case, the opposite is the y value, and the hypotenuse is the radius. So sine is y over r. Likewise, cosine would be the adjacent over the hypotenuse. But the adjacent, if we look at the picture, the adjacent is this side, the x side, and the hypotenuse is the radius. So I don't know what just happened, sorry, I'm sure that was just really weird that I just said that, but for tangent is opposite over adjacent, and so the opposite side is y and the adjacent side is x. Now if you remember, cosecant then is the reciprocal of sine. So if sine is y over r, then cosecant is r over y. And secant is the reciprocal of cosine, and if cosine is x over r, then secant is r over x. And cotangent is the reciprocal of tangent, so that would be x over y. Now you'll notice I have this whole other column here. So I have this whole column here. And the reason I did that is because we are so used to working with, instead of r, we're working with the unit circle, so r is 1. So then that means if r is 1, sine is y over 1, which is just y. So in essence, sine is the y value. Whatever that y value is your sine value. So it makes it a lot easier. You just have to know what y is. And cosine would be x over 1, which is just x. So cosine is the x value. Tangent is still y over x because there is no r value to mess with it. Cosecant then would be the reciprocal of sine, so that would be 1 over y. Secant is the reciprocal of cosine, so that would be 1 over x. And cotangent is the reciprocal of tangent, so that would be x over y. And so that is where our unit circle comes in. We were really focused on a unit circle where, let's say the x value is, let's go here, and let's say we're working a 30-degree one. And so the x value, if you remember, the x value was root 3 over 2, and the y value was 1/2. So then if I want to figure out the sine of 30 degrees, is all I have to do is look at the y value, which is 1/2. And the cosine of 30 degrees is the x value, which is root 3 over 2. So it makes sine and cosine really easy for us. We just have to know those values. And so we have to be able to think about what is root 3 over 2 and what is 1/2 for our y value in order to do that. So then we actually have to do some practicing with this so that we can figure out what sine and cosine is pretty quickly without actually having to draw the unit circle. And so that's what we're going to have to work on in class, is being able to recognize the x and y values for 30 degrees and the x and y values for 60 degrees. Just remember, it's really nice because we don't have very many numbers to work with. We have root 3 over 2, we have 1/2, and then for the 45s, we have root 2 over 2. So it makes it pretty simple for us. Now tangent, on the other hand, is not going to be as simple because tangent of theta is going to be the y value 1/2 over the x value root 3 over 2. And so now all of a sudden we have this fraction business to work with. But let me clue you in on a little trick. If your denominators are the same, you can just cross them off. And this only works if it's the denominators. If it's the numerators, you can't do this. But now we have 1 over root 3. And so now we just got to simplify by rationalizing. and we get root 3 over 3 for our tangent value. So tangent and cotangent take a little bit more work, but ultimately it's still pretty easy to figure these things out.